How are you? For sure you know it. You stare into the computer, into the grasshopper definition, and you have this tiny bit. The script works, but it doesn't work as it should, and you just cannot figure it out. Well, first of all, that happens to everybody, including me, and it doesn't matter really how long you used Grasshopper before, it just happens. And it's a good thing because you learn actually way more. You learn way more with the mistakes. And another good thing is that if that wouldn't happen, I wouldn't actually look into Honeybee in the first place, because somebody had exactly that problem. They've built a script, it works, but it doesn't work as it should. They came to me and said, Philip, maybe you know what the problem is. And I said, I can look at it, but I cannot promise, because I also haven't looked into Honeybee for a while. But because I actually had a similar problem before with Ladybug, I could help very quickly. Yeah, and that's why today we have our first Honeybee introduction. So we will look into Honeybee, what we need to install, and we will use the latest Ladybug tools 1.2, 1.1, 1.1.2, no, 1.2. Let's check it out. Yeah, 1.2. Yeah, on that note, a big shout out to the guys who actually sent me the question, the script, which didn't work. It actually worked fine. My brother from another mother, Leonardo Gindri, he has his own channel, which is
Oficina Paramétrica.
Oficina Paramétrica. And because Grasshopper is not just Ladybug and Honeybee, so he talks about everything about parametric design, Grasshopper, of course, Rhino.
Isso. Como é que a gente faz isso, tá? Vamos lá. Por exemplo, o meu ponto veio pra cá, que eu tava olhando outra coisa. Deixa eu referenciar eles de novo, tá? Certo, multiple.
Yeah.
Só, alguns ele vai puxar e outros ele vai, ó, espalhar. Ok? Dá pra aumentar os raios também, ó. Por exemplo, ó, esse ali que tá afastando, eu quero que ele esteja mais afastado, e os outros eu quero que ele puxe mais. Tá? Ou, na verdade, como estava antes, estava bem legal.
Done.
No efeito B. Ó, dá um efeito bem legal. Bem show de bola.
Yeah, he sent me the script and said one of his students, thanks, by the way, don't know your name, thanks to one of his students, she built the script and she didn't know what the problem was, and I can quickly share, it can show you the script and what the problem was, and then we can rebuild the script together. Okay, thanks Leonardo, and let's catch up sometime. I have this here twice, actually. Yeah, this is the definition. It's basically a Louvre. It's a daylight study, annual daylight study, which measures how much daylight it goes into the room, and then measured with open louvers and closed louvers, as you can see here. And the problem was that although you have open louvers here and closed here, the result looks almost the same. There's some difference, but it almost looks the same. So you think like, that can't be right. That can't be true. So we will look into that. We will first go through what we need to install for Honeybee, and then we will look into that problem. What I can already tell you is that yes, it looks very similar, but when you look at the numbers, it's not very similar. Actually, here with the open louvers you have 65, and here you have a bit more than half as a maximum of sunlight. So yes, okay, let's go first through the installation. Yes, so we go to Ladybug tools. Actually, we can go to Food for Rhino, because that's anyway the place to look into, and then Ladybug tools, and here of course you need to log in, and then the latest Ladybug tools, the 1.2.0. I had some issues with the installation, I have to say, but yeah, you download it first. You download it, and when you have downloaded, you can go into your folder, Ladybug Tools. This is the Ladybug Tools 1.2.0, and you just go in here. You copy the link, open document, installer, and then you just need to follow these instructions here. I will not do it again because I did it before, and what you need to do is to really follow along, and you will need to install Radiance, and also there's another tool which we need later for the Honeybee energy calculations. We will not look into that today, but definitely what you need to have is Ladybug, and I recommend the latest version, and then you need Radiance. Install Radiance, and it will tell you here exactly what you need and where you can find it. So you need to run this, and then you need to run here the second one, so it will tell you exactly. However, important, I had some issues. So when I installed the Ladybug 1.20, actually nothing worked. It completely messed up my Grasshopper. So in that case, you can go in here, special folders, any of these actually. Need to go here, I think user object, user objects, and then here you just delete all the Ladybug tools, not Butterfly, because this is a different installation. You also need to go into your Ladybug. So when you're here, user, and then your name or admin, depending on what you have as a username, and then into Ladybug tools, and just delete whatever is here. In some cases, you also need to run this. So you need to install it, close everything, close Rhino, and you close Grasshopper, and then you run this here, set Python path, and then you can start. And I would also recommend then starting Rhino as administrator. That's so to the installation. If you have any question, I can, let me know. Just send me a text. Then here, when this is done, you should see Honeybee 3 times. You see the Honeybee. This is basically building the model, the Honeybee model, and then you see 2 other bits. One is the Honeybee Radiance, and the other one is Honeybee Energy. And we are looking into Honeybee Radiance. I'll just make another version, another box here. This is gonna be our room. This is the object we're gonna test as a room. And normally in good classic Ladybug tool style, I always start with the solver, because it just leads me to whatever I need. So in that case, we want to do an annual daylight study, and the annual daylight study you can find in here. This is annual daylight. You have daylight factor. We can talk about this also, and direct sun hours. So we can. So this thing is here, and we can just grab it, or you type it in, just double click, and annual daylight, it's gonna be the same. So let's don't look so much here, but actually see what's in here. What do we need to provide? Okay, we need a model. We need a Honeybee model. So we will find, and again, this is typical Ladybug tools. Mandatory input is with the underscore at the beginning, then underscore at the end means it's optional, and then if there's like an underscore at the beginning at the end, then it's a mandatory, but there's a default value. I said that already so often, but you cannot say it often enough. We need a model. Here's written: a Honeybee model for which annual daylight will be simulated. Note, this model should have grids assigned to it in order to produce meaningful results. Okay. And I guess, so we have different options here. We can deconstruct the model. We can have a Honeybee model. We have this here. It's the Honeybee room from solids. And I think we need this one, the Honeybee model. So if I put this in here, it doesn't say it's wrong, but also doesn't say it's correct. We need a weather data. The weather data come with the Ladybug tools here. So we can go into here, download weather data. Let's get a panel. We need this. We want to look up the model. Let's get a toggle here. Toggle, Boolean toggle. If we double click here, let's choose my location, copy to clipboard. And now we have the weather data here. Let's see what we need in order to get that into Honeybee. So let's just type in WEA. Let's see what we have. Honeybee WEA from E plus weather data. I guess that's the one. So we need this tool to connect. And now we have the WEA tool, which goes into here. And what else is mandatory is this here, the run button. So we just copy the toggle and yeah, it of course it doesn't work because the model needs to have a grid assigned. Also, there's nothing in there. So if I would know all these, then I would probably assume, okay, I need a room. Let's check that. Yes, so we need a room, and that is Honeybee room from solid. That looks good. So geometry. Okay, so now we have one room assigned. That's good, and we can hide this. And yeah, and then you can see what the problem is. We can also put here a report. Error. Result folder contains no grids info. Okay, so I saw this here, grids. So I would assume the student was using this here. Assign grids and views. Okay, let's try that. Assign grids and views. And it needs to input a model. And there are no grids yet because we need to define grids first. So I will assume that this is the right one. Grid. Ladybug generate grid points because we need the positions of the points. And we want to have the points generated on the floor. So what I think need to happen is I need to understand the rooms. So if I would just use geometry, it doesn't really matter. It doesn't really work. The grid size, that's pretty straightforward. Let's see how that works. Let's have 1 meter. But we're just trying things here, okay? And that worked. And now we look into here. Can I actually see the result? It's interesting, it's all the same. It's gonna be a weird result, but we can take that, the heat map. So if you go here into Ladybug, you get the heat map. This is the one here. We can feed the values from here. Yeah, and we need the mesh. That's pretty cool. So we can use the mesh from here. And of course, yeah, it's a weird kind of result. And now I'm thinking this is probably the percentage of daylight. Okay, anyway, we move forward. Of course, now we don't want to have, we don't want to measure the block. For that, we could just use Ladybug. We want to create louvers and measure what's inside. So how to do that? There are different tools here. The visualize by type, meaning type, for example, door, floor, wall, ceiling. Let's try that. Yes, so that, let's turn that off here. And you can see there are polyline curve. These are the outlines, I guess. So wondering if there's a different way to do that. Yeah, so far, okay. I can basically from the room I can filter different things out of here. But it's funny that it's called exterior floors. It shouldn't be exterior floor. So this is our definition so far. We have we use our geometry to build a room, and from the room we built the Honeybee model, which we then apply a grid to. And because we want to test what's in here, what is the light, the daylight on the floor of that room, we try to filter the floor from this room. Now let's check this here. Because we need to provide an offset. So we need an offset in order to not overlap the geometry with the result mesh. And of course we don't get any sunlight, so nothing's showing at the moment. Yeah, another thing what she did here, actually I completely forgot that this option works. You can actually build a wireframe of your object. Let's do that. So wireframe. That here, and then we can hide this. No, this one. Yeah, that looks already better. I'll turn this off here because otherwise it's gonna run all the time. So here we got the floor. Don't ask me yet why this is called exterior floor. We will figure it out. In here, I think. Yeah, it seems like this doesn't work as I want. So we can select from here, we can select by list item, and we can select, and that should be okay, no, it's not. Five. So with this tool we can select the face we want to check out of the from the model, and you can see here the offset. This is the offset here. Let's keep it like this, and yeah, you can see minus because it's flipped, and it's because from that solid the face would face that direction, and in this case it goes upwards, inwards. Hope it makes sense. So this is the basic setup, but now we have the problem that there is no light coming into that solid. There's no light going in. There's no window. So we need to create windows. We can do that with, I hope. Oh no. We need to go here, and we need this one. Apertures. Add apertures to Honeybee's face or room, given a ratio of aperture area to face area. Okay, let's try this. Let's see what she did here. That's interesting. So the room goes in here, and then you can choose. Okay, I think I know already. This goes in here. Now you need to choose, create a ratio. This is with this one. Because what Honeybee does, it's already understanding from that block that this is the floor, these are the walls, and this is the ceiling. So with this one, the facade parameter, you can choose the wall, which side you want to create the opening. Put a slider. And of course now you don't see anything. So if I go in here now, you can actually see the opening, but now this has changed. This is not ideal. So I want to try something here. Let's try this. Yeah, so wait. It's not that simple as I thought. So in order to make sure that I always choose the ground. So in this script, very cleverly, basically visualize the different faces by type, and then select via an item list the floor face, and that was basically put into the grid. Now the problem is that every model orders the faces differently, and if you choose a new model, then you might need to adjust the number here on which face you're gonna select. So in order to make sure that it's always the ground, I actually can use this tool here, organize separate faces by BC. I'm not sure what that means, but it includes outdoor, surface, ground, adiabatic, and other. And the other one by type, it's also possible. So you can choose either the one or the other, and that gives you the exterior. There's like, you can see there's one face in here, exterior floors. And it's the same as here, the ground. Room 4, phase 4. That's the ground level. And if I have a different model, then and I feed it in here. So for example, I have 2 models, then it will always choose the ground face. So that way you can make sure that you always choose the ground, or the face you want to test. So that's maybe an improvement that could be improved. And then you could make a copy of this, because we still want to have the wireframe. Turn this off. Also this. Don't want to see this. And use this wireframe here. I hope you can still follow. So I didn't run the script yet. We created this opening, and with the facade parameter we can choose the percentage of, or the factor on how much this is opening, and then we can choose here on which side it is, right? So we could also choose another additional side. Now it does that for both objects. And disconnect, or I can, no, let's keep east, let's keep it the same way. And then I choose all my objects again from this point. So I could have done it from here, I could feed all these in here, but then I miss a bit, then I miss the other information. So I would always then go from the latest version of my model into all this here. So actually now we could already run it. Let's see, let's test that. No, that doesn't work. Why? Let's simplify that. It seems like there's an issue with the two, running the two together. Let's start first with one. Okay, we're not yet there. There's something wrong. Something is wrong. Of course, I understand. Okay, so at the moment it doesn't actually get any light in there. The reason is that I'm feeding my room into here, into the model, into the Honeybee model, and actually I need to feed in this here. So when you look at that, there's also the room number 9. And now it should work. And I'm pretty sure the number here means percentage and not the hours. And now we add the louvers, and let's see. Let's do this. Okay, we have the model here. Now we need to add the louvers, and let's learn from the student. So she, I think is a girl. She just added the louver so she modifies basically the room and adds louver shades. So these are this one. Add shade, add Honeybee shades. Okay, let's try this. Let's do the same. We can then do variations of it, or you can try at home. So here, then this. Let's turn this off. This one, and if we feed that back here. Doesn't show anything yet. Can have the shade count. Let's add a number. Slider. Shade count. So So we also need the depth here. And yeah, this is important. We do the right thing right away. We need to feed this in here and feed this in here, so you can see the shade counts. And I have basically a vertical, horizontal version, and we can try. Let's have a look. And that way you can then also check what works better in your case. What else can we check? We can change the depth of the louver. As you can see, when I change the slider here, it becomes longer. The amount, the offset from the facade, how far is it from the facade? That's also possible. And the angle in degrees. So we can have a slider here with 360. Angle. And you can also have it inside, of course. I guess you can just have a boolean value, either yes or no. Toggle. Yes. Boolean value can change that to either vertical or horizontal. And here you can also have another one. And we can flip it very easily. So we kind of rebuilt this here, and yeah, you can of course play around with it and then run your test. Also an interesting result. Now, okay, that should be clear. Let's go through it one more time so you can better understand. So we go from here. We have the geometry. This should be a simple block in that case. That will be defined as a room that goes into an object called Apertures ratio by ratio, and you can build different apertures, as I understood. And you choose, basically you build a window into one of the walls, and then you add this factor, the ratio. You choose the side on which side this window should be, and the ratio. I don't want to change it now because it restarts the calculation. Let's see how that changes if I change this here. Yeah, it changes the height. And then you have other options here, and you can actually define, you can subdivide it even, that we haven't tried. You can have the window height, how high is it, where does it start, and so on. Then we added the louvers, and this can be vertical or horizontal. You can change the depth, the amount of louvers, the offset, outside or inside, and the angle. And from there, creating this basic model, we define it as a ladybug, as a honeybee model in here. And that model we assign a grid which we only apply onto the ground. And to get the ground, we feed this in here, the organize by object or by type, and choose the ground, and then basically get this visualized by type, which is for sure there's a more easy way to do it. But yeah, and then we take the wireframe, create a surface, feed that here into the grid, generate grid tool, and that goes into the sensor tool, grid sensor. We get the position and the direction, and that goes and that applies basically the grid onto your Honeybee model, and then that goes into the solver, the annual daylight solver. And then you have the data, the result comes out of here, data, and there are different types which we can have a look at in another video. Or maybe let's have a look now. Let's see if there's anything we can have a quick look from the output. Let's see what's in here. So we have different outputs here. I'm pretty sure this is about the percentage, and What's in here? Continuous daylight autonomy result. Put the values here. Let's see how that changes it. Useful daylight illumination result. So what the useful daylight. So it's a matter of about reading about these outputs, because yeah, we can make a test, but then if we don't know what that actually is, then it's a bit of a problem. So one thing to look at now is why is the closed louvers and the open louvers, why do they look the same, almost the same? But here you can see the numbers are very different, and we go actually back to the original definition, and you can see this is the output here, and this is the one here. So actually it's very simple. It's very simple. You just need to know it, and that decides over success or not. Here is a tool called Legend Parameters, and I can put this into the heat map. It has a slot for Legend Parameters, and in here I can take the minimum. I can define a minimum and a maximum, because what's happening in the heat map just takes all the numbers and chooses the minimum and the maximum from the set of numbers. So if my numbers are from 0 to 35, whatever that is, percentage or hours, I don't know, we don't know yet, then this is my range, and it will basically divide the colors based on that range from 0 to 35.12. And the same happens here. It will divide here the minimum is 3.46 and the maximum is 65. So we would go for both extremes actually. So the best would be to go for both extremes. So here we have 0 and here we have 3.46. Now 0 is lower, so the minimum should be 0. And because we want to compare this with this one, the minimum need to be 0, and let's copy this. And put this in here, and then my maximum should be the one I want to compare it with, the bigger number. So the open louvers get more daylight than the closed one. Here's 65.09, so that should be my maximum. And you can take the maximum from the list, or you just type it in. I type it in. Even better, let's do 100% or the 100 as my maximum, because I think it's percentage. Let's take 100 as a maximum. It looks already much different, much more different. And we do the same here. And here you see it's very different, because we had the maximum, as you can remember, somewhere around 38. So that's basically around here, and that's the difference. It's actually really just looking at the output. We can use this here as well. Yeah. See. Anyway, I hope you enjoyed that episode. Subscribe. Leonardo, thanks again for the task. See you next time.